Hi, welcome to this edition of GCSE Science Class Notes, revision and exam question practice. Today we'll be looking at electrolysis and half equations of molten ions. In a previous video, I looked at electrolysis of aqueous ions. But before we start, here we go. Here's a little joke. What is the difference between Iron Man and Aluminium Man? Yes, Iron Man stops the villains, whilst Aluminium Man foils their plans. Yeah, I'm really sorry about that. But anyway, today's lesson is on aluminium and separating aluminium. So aluminium is extracted by electrolysis. So aluminium is formed by a mixture, excuse me, and we can extract it by using electrolysis. But aluminium oxide is an ionic compound. It is made up of aluminium and oxygen, and it cannot be extracted. So like true traditional revision practice questions, what I'm going to do is I'm going to show you the questions, and then what we're going to do is you can pause the video, have a go at the questions, and then have a look at the answer, the way I break down the questions. Alternatively, you can stay with me. So this is the resource from one of the questions from a past GCSE paper. This is what they gave, figure 2, and related to figure 2, these were the questions. So question 1 was worth 1 mark, while question 2 was worth 3, and also question 3 was worth 3 marks. So feel free to pause the video, have a go at these. You can even go backwards on your video to have a look at the figure 2. And you can check the answers with me as we go through. Alternatively, stick with me. Let's have a look. Okay, so aluminium extracted by electrolysis, process of removing ions, the mixture of aluminium and oxygen. So let's see here. Aluminium, Al, that's a solid. That's an element, is extracted by electrolysis. Electrolysis is use of electricity to split a mixture. So the mixture that we have here then is aluminium oxide. There it is, Al2O3. Usually most exam questions will give you that formula, otherwise you can work it out. Also, we've got then molten aluminium. So this is the aluminium solid that's been separated from the aluminium oxide. Let's have a look at the hardware then. We've got here we are, we've got a positive electrode called an anode. Now these are made out of carbon or graphite, and we've got a negative electrode also made out of carbon, or more commonly as graphite. So we've got two positive and negative ends. Of course, the positive end will attract the negative charge, and the negative electrode will attract a positive charge. Right, so let's have a look then. If we split this molecule, we've got a metal and a non-metal. It's an ionic bond. Therefore, we have aluminium is a metal, so it'll have a positive charge, and we have oxygen, which will be a negative charge because it's a non-metal. So the charge on the aluminium is 3+, of course, because it's in group 3 and it's a metal and it loses 3 electrons, of course. And we've got oxygen, which is in group 6, and it gains 2 electrons to have that full octet, or 8 electrons in its outer shell. So these two are a mixture which are bonded together in this compound, ionic compound, so they need to be separated. Before we can consider separating of these two, we need to consider what happens. Now, aluminium has a very, very high melting point, around 2000 degrees centigrade, really, really high. That's lowered by this stuff called cryolite. Cryolite is added to aluminium oxide to lower the temperature. It in fact goes down to about 1000 degrees, so it's significantly less. So this whole apparatus is heated up to about 1000 degrees roughly to help with this. Now when you heat particles and you melt them, they will then become mobile. They'll become free to move around. When they're in a lattice ionic state, so lattice bonding, they will not move. They can't move because they're fixed in place. So we release them, if you like, separate them by putting them in cryolite and heating them. This makes them mobile. That's all it does. They're still not separated. We still want this stuff, aluminium, for various uses. Now, comparing this to extraction of aqueous ions in solution, it all goes down to this idea of the metal reactivity series. What happens is we've got the metal reactivity series is a series of metals put on a list, and they have certain positions and certain reactivities. If you recall, anything the higher you go on the table, the more reactive are the metals. The lower down on the table, the less reactive, which is a good thing, because the ones at the bottom, you want them not to be reactive, because we use them for more useful things like jewelry or copper wiring. And the reason for why this happens is because higher up on the table, these metals prefer to be in their ion state, so they prefer to give up electrons, or if we use oil rig to describe this, they're oxidized. They're oxidized forms they're quite happy to be in, compared to the ones lower down, so beneath hydrogen, which is not a metal, of course. Those metals prefer to be in the element state, so they will are reduced. They're happy to gain electrons. That's the way to think about this table, I guess. If we look at this, anything below hydrogen or carbon can be quite easily separated with electrolysis, but anything above carbon is more reactive than carbon. They won't react directly with carbon. That's the thing. So that is why aluminium cannot be extracted in the normal processes or normal ways of using aqueous ions. So we need to use this apparatus, this setup. Back to aluminium oxide. So aluminium oxide has it's not soluble in water. So if you put some aluminium oxide metal into water, it doesn't dissolve like sodium chloride, for instance. Sodium, of course, potassium chloride, higher up on the periodic table, they will quite happily dissolve, but aluminium oxide will not. So we need to heat it up, and that's the reason why we need high temperatures to cause that mobility. Now let's have a look at the reactions, see what's happening at the electrodes. So I've got my aluminium oxide. Just to go over this, aluminium oxide is Al2O3. That's its formula. And at the positive electrodes and negative electrodes, we have certain deficiencies or buildup of electrons. So for instance, at the positive electrode, at the anode as it's called, there is a lacking of electrons. So the electron's missing, if you like. Whilst at the negative electrode, there's a buildup of electrons. So once we've heated this in cryolite, we separate out our ions, and we've got these two ions. What happens is, because they're mobile, the Al3 will be attracted to the negative electrode, of course, which is the cathode here. Now, the reaction that takes place there is aluminium then will pick up 3 electrons, because remember, at the cathode, there is a surplus of electrons, a buildup of electrons. Therefore, it will become its element, aluminium solid. Now, at the other end, at the anode end, where there is a deficiency of electrons, this oxygen ion will diffuse or will migrate to the to that part, because opposites attract, of course, because there's a positive charge here and this is negative, so there is a attraction there. They move across. So what happens there then is oxygen will then or the oxygen ion, I should say, will then lose its electrons. There they are. Okay, in fact, there it is. In fact, there's two negative charges, so it'll lose both electrons. There it is. Then I'm left with O. Now, there's a problem here. Oxygen is diatomic, so there's always a little 2 by it. Okay, so when it forms oxygen, 2 atoms of oxygen come together to form oxygen. So what happens is I've got 1 ion of oxygen, so 1 capital O, and 2 capital O's on the product side. They're not balanced, so we need to balance this. The only way we can balance this is by putting a great big 2 here. On the reactant side, I've got 2 O's then. Now let's have a look at the charges. I've got an overall charge of 2 times 2 minus, 4 minus here. I've got an overall charge of 2 minus here. I need to change that. I can rub this out with my razor here and put a great big 4 here. Now we have a balanced equation. One further thing happens now. These electrodes are made out of carbon. Oxygen can also react with carbon. So in fact, carbon is reduced according to oil rig because it gains oxygen. And that equation is carbon solid which is the graphite, added to oxygen, makes this stuff CO2. This is a gas, that's a solid, and this is a gas. And there we go. We've got a reaction that takes place. Now, when that happens, the carbon is worn out, it's used up, because the oxygen will react with it to form carbon dioxide gas. So over time, engineers, etc., would have to, or technicians would have to replace these anodes, these graphite anodes, so to keep the reaction going. And then, of course, we've made molten aluminium. Right, so let's have a look at the questions then. So with this in mind, why can aluminium not be extracted by heating aluminium oxide with carbon? Well, we've discussed that for 1 mark. We go back to that idea of the table, and aluminium is more reactive than carbon, or we can say carbon is more reactive than aluminium. Therefore, we need to heat aluminium oxide up. Question 2, which was worth 3 marks, says explain why aluminium forms at the negative electrode during electrolysis. Remember, it's not just a 1 mark question, it's 3 marks. So we've got to say 3 points, if you like. This is where the equations come in to show that once the attraction has happened, there's an exchange of electrons, etc., going on at that part. Let's have a look. So that will be this idea. So aluminium ions are positive, they're attracted to the negative electrode, of course, where they gain those electrons to become aluminium. And then part 3, here we were looking at explain how aluminium, it says explain why carbon dioxide, or how carbon dioxide forms at the positive electrodes during this process of electrolysis. Well, we know that the aluminium ions are negative, they're attracted to those to the positive electrode. So what happens there then is we get a reaction between we get the oxygen losing the electrons and then picking up carbon dioxide out of the graphite. And so here we talk about oxygen being produced. You don't have to write the equation there, but you could have done. It's not, doesn't mean you're going to lose marks. It just shows high order thinking. And then the oxygen will react with the carbon dioxide to give the carbon dioxide fumes there. I hope this helps you with your revision and exam practice, exam question practice. If this has helped you, please let your friends know. Please subscribe and give us a thumbs up, etc. Again, sorry for that joke.